Hi everyone, this is Ms. Bergen, and I'm here to present to you the third day on sequences in the series. Now, hopefully there won't be anything really new in here, and we apologize for not being able to teach this directly to you ourselves, but we just can't afford another day, or I really shouldn't say another day. I should just say we can't afford to lose a day of instruction. So, happy holiday, happy Labor Day. Hopefully you're watching this before Labor Day, so you're getting it out of the way early and you can really enjoy Monday as a day off. That's my plan. I'm going to try not to have to do schoolwork on Monday. But anyway, back to the topic at hand. So sigma notation is how this thing starts. And then we'll move into some more word problems just for some more practice for you. Okay. So again, something you should have learned in IM3, I do believe. So suppose someone gave you an arithmetic with an arithmetic series. Okay. You can use sigma notation to write this series. So it says, for example, the series above can be written using what we call summation notation or sigma notation, means the same thing. So this particular series right here equals this expression right here. So the idea is if I put, and let's just double check that it works. If I start with the number 1 and I put it in for n, I should get the first term of the sequence. So let's see if this works. So 2 times 1 is 2, minus 1 is 1. So far, so good. Let's put 2 in. 2 times 2 is 4. 4 minus 1 is 3. Working so far. Let's try 3. 3 times 2 is 6. Minus 1 is 5. The sigma part means that you're adding the terms. So as you can see, if I put each number in for n, starting with what it tells me to start with, I'm getting the first 3 terms. I could keep going. Eventually, I'm going to stop where it tells me to stop, which is the 8 up here. So 2 times 8 minus 1 is 15. And you can see, yes, indeed, it does stop. Let's talk about a little vocab here. Okay, the n equals 1, where it starts here, guys, is called the lower limit of summation. So it tells you where to start. What do I put in to obtain my first term of the series? Then it tells you upper limit of summation is when to stop. So when I put in my upper limit, that's the last term of that particular series. And then this is the rule. So this is going to be, if it's arithmetic, it's going to be linear, because if you actually graph the terms of a sequence that's arithmetic, you will get a bunch of dots that are basically collinear. They're going to be in a line. So this should be a linear expression. If it is geometric, then it will be an exponential expression. You might remember this stuff from IM1, you might not, but trust me, you learned it, okay? All right, so let's give this a try, guys. So the idea is for us to write the rules. So suppose everyone asks you, like in number 1, to represent this using sigma notation. There's really 3 things you need to know. Number 1, what's the expression? That's where I would start. Number 2, where do I start it? Number 3, where do I end it? Okay, so let's see how this goes. So hopefully you've all printed out your notes by now, because it's up in your classroom. Okay, so I'm going to start with the expression, guys. Now this is, first of all, decide what kind of a series it is. Well, I think you would agree with me. This is an algebraic series. I'm going to write this down so we will remember. Sorry, I said algebraic, I meant arithmetic. They both started with an A. I don't know. Don't ask me where the brain is. All right, it's an arithmetic series. So since it's arithmetic, we want to basically use our formula. U sub n equals U sub 1 plus n minus 1 times d. And we're going to put in everything that we know, not the n, because again, we're looking for the formula, working for the rule, if you will. So U sub n is equal to the first term, which is 67, plus n minus 1 times my common difference, which in this case is negative 4. I want you to clean it up a little bit. So distribute, add like terms. If you do it correctly, you should get negative 4n plus 71. I'm going to double check that I'm right before I move on. So if I put 1 in for n, 71 minus 4 is indeed 67. If I put 2 in for n, I'm subtracting 8. Yeah, okay. So I didn't make any silly mistake. All right. So yeah, I told you there's 3 things you need to know. 1 is the expression. We've got that. So we've got our rule. We need to know where to start. Well, if you just do what I did and you just use our formula for the rule guys, you're going to start at n equals 1. If you decide to look at this and try to figure out your own formula, then n could start almost anywhere. But I would suggest you just go with our arithmetic sequence formula, as I just did, and then n equals 1. Okay, so the other thing you need to find is where does it stop? So we need to figure out what number do I put in that will give me a 3 back. So everyone, you've got the formula right here. So we're going to plug in right into that formula. So that's what I mean. Replace your u sub n with the last term of the sequence. So 3 equals a negative 4n plus 71. We're just going to use the formula that we just created. Subtract 71 from both sides. Negative 68 equals a negative 4n. Divide by sides by negative 4. And n should be equaling a 17, if I've done my math correctly. Hopefully I have. Okay, now we put it all together. Now we're ready to write it. So first you have to draw, to the best of your ability, a sigma. Okay? You start off with what you would like n to be. As I mentioned, we're going to start it with a 1. As long as we use our formula, it's a no-brainer. You start with 1. We're going to end it with what we just found, 17. And what do I put here? In parentheses, you put in negative 4n plus 71. And that's your answer. Now, everyone, this is a new topic. So Mrs. Jensen and I have done the best we can to try to figure out what IB might do to you, because we've never had to teach sigma notation before in, what was the math studies course that is now mathematics applications and interpretation. So, hopefully we're guessing right on what they're going to ask you. Okay. I've taught sigma before, just not in this course. All right, so let's go to B. Now, taking a look at B, this does not look arithmetic to me. This looks like it's going to be geometric. So if it's geometric, we should be able to find the common ratio. I'm going to have you try to figure that out while I write the word geometric up here. Okay. And hopefully everyone's noticed that to get to the next term from the previous term, you would multiply by a negative 1/2. You can tell it's negative because every other term is negative, okay? And it's a 1/2 because, again, how do I find it? I take any term and I divide by the previous term. If I take a negative 1/2 and I divide by a 1, I get negative 1/2. I'm convinced. Okay? So again, you need the same thing you did before. We need the formula basically for a geometric sequence. So let me remind you of what that is. U sub n equals u sub 1 times your r to the n minus 1 power. Since my r is negative, we're going to be good and put it in parentheses like we're supposed to. Okay, so u sub n is equal to u sub 1, which is technically a 1, times negative 1/2 to the power of n minus 1. That was easy. You don't have to do anything else with that. All right, now the harder part is we need to figure out how to get which term is negative 1 over 1/28. Okay, so I'm going to do exactly what I did over here. Negative 1 over 1/28 is equal to a negative 1/2 in parentheses raised to the n minus 1 power. Okay, all right, now you certainly could solve this problem using logarithms, but let me help you out for a second, guys. There's going to be an easier way. We know n has to be an integer, okay? In fact, I know more than that. I know n has to be an odd integer. Want to know why I know that? Because it's equal to a negative number over here. So if I have a negative 1/2 raised to an even power, and when I say even power, I mean the whole thing, then this number here is going to turn out to be positive. So I know that whatever the exponent is here, it's got to be an odd number, which means n's even, by the way. Yeah, it sounds a little weird, but that's how it works. So I really don't have to sit here and do logs. Plus the fact I think it would bug you a little bit because if you try to do logs, you can't take the log of a negative number. So you kind of have to ignore that negative and it starts getting a little messy. So I would say forget the logarithms in this case. You don't have to. I would do, I would basically just sit here and see basically I can rewrite this one. That's kind of where I'm going. I can rewrite negative 1/28 as negative 1/2 to a power. Again, because I know n's an integer. So why don't you guys take a moment and why don't you play with your calculators a little bit and why don't you try to figure out 2 to what power is a 1/28? Okay, so I'm going to pause my video. You should do the same and I'll find out what that would be and then you can find out what would that be and then we'll compare. All right, I'll be right back. Pause your video. All right, I'm back. Let's see how you did, guys. So I found that if I raise negative 1/2 to the 7th power, I would get the negative 1/28. Again, I didn't really put all this in the calculator. I just did 2 to the 7th and looked to see whether it was 128, which it is. Now, that does not mean that n is 7. It's negative 1/2 to the 7th equals negative 1/2 to the n minus 1. Now that I have the same bases, I can set my exponents equal to each other, and I get n equals 8. Okay, so now that n equals 8, I'm ready to write my sigma. Okay, let me scoot my paper over a little bit and ignore if you can hear my doggy barking out there. Apparently the dog next door is also barking at my dog. They have lots of fun barking at each other. All right, so I don't really need that 1 in front. I'm not going to worry about that. I'm just going to put a negative 1/2 to the power of n minus 1. And I'm going to say that n equals 1 and it ends with n equals 8. Okay, and that's how you do that kind of problem. So that's how you rewrite it in sigma notation. Okay, all right, so the next problem is going to ask us to expand it and then find the sum. Okay, now you could go with a fancy formula, but you're going to see in a second, why would I do that? Okay, so I'm just going to write equals. And we're actually probably just going to do a bunch in our head here, guys, because I think you can handle it. All right, we're going to start with k is 3. 3 times 3 is 9. 9 minus 7 is a 2. Plus, we're supposed to write it as an expansion, so we want to make sure we're showing it as a sum. I would now put 4 in for k. 3 times 4 is 12. 12 minus 7 is 5. It tells me when to stop. I'm going to put one more number in. 3 times 5 is 15. 15 minus 7 is 8. Okay, and since it said start at 3 and end at 5, there's only 3 terms there, and that's all that we have there. So if you're asked to find the sum, I hope we wouldn't go use a fancy formula. For heaven's sakes, guys, you got the terms right in front of you. Why don't you just go ahead and do it? I'm just going to write that the sum is equal to 15, and I'm good to go on this problem. Okay, so that's how you do that. Nothing too hard about that one. All right, now number 3 and 4 ask us to find the sum of each series. Let me move my paper a little bit so you can see that better, and I have a little more room to write. All right, so find the sum of each series. So the first thing is you want to know is, well, let's back up a second. So I want you to think about the formula for the sum of the series. Okay, so if we go with arithmetic, let's go to the IB formula. Okay, for example, to use the IB formula for the sum, I can use, well, I know I keep going back and forth in my head. Tell you what, this one, I probably wouldn't bother with the IB formula, but you certainly could. But let me show you what I mean. Because they have told me to start at 1, I know if I put 1 in, I can get my first term. Oh, notice the last couple problems didn't use an n like I did above. It used a k here and an I here. It doesn't really matter what you use. Okay, just be consistent. If you say I here, you have to have an I here. If you say n here, you have to have an n here. It really doesn't matter what you use. For some reason, they tend to use I quite a bit, but you know, n's fine. So anyhow, as I started to say, if I go to your formula from Algebra 2, or sorry, most of you can go through Algebra 2. I am 3, let's go there. I am 3. And my guess is most of you, if given a choice, would go with this formula if you believe it's arithmetic. okay, rather than the IB formula, just because you're not so used to it at this point. You haven't had as much experience with it at this point. So if we're going to go with the formula again that you're more used to, we need to know three things to find the sum of the series. The first thing we need to know is how many terms are in this series. And you don't want to start counting on your fingers. Well, 1 is the first one, and 2 is the second one, and 3 is the third one. You don't want to do that. There's an easy formula, guys. What you do is you take your upper limit of summation. So I'm going to write down that, I'll say n for number, okay? So I'm going to say my number is, you take your upper limit of summation, you subtract your lower limit of summation, and then you always add 1 to it. I'm going to say that again. If you want to know how many terms are in the series, you take your upper limit, you subtract your lower limit, and you always add 1. If you don't add the 1, what you're doing is you're finding partially how many are between, but you're not being inclusive for both of those numbers. Okay? It's like if I tell you read pages 4 through 7. You might think that there's only 3 pages. No, there's 4. Page 4, page 5, page 6, page 7. That's 4 of them. But if you just do 7 minus 4, you're only going to get 3. You always add 1 back on. Okay. So n equals 28. Now you might say, well, Ms. Bergen, come on, really? It said 28. Of course it's 28. Well, I agree with you because it starts with 1. But once in a while, they may start you with something other than a 1. And if so, I don't want you making the mistake of saying, oh, this starts at 3, this ends at 8, there's 5, because there are not 5 there. Okay, so that's why. And again, we don't know what IB is going to do to you. So I'm just throwing in all the tricks I can think of that I've taught my students in the past that hopefully if IB does it to you, I've prepared you. And if not, well, then you'll come back and you'll complain to me in May and I'll say, oh, next year I'll have to let them know this. Okay, so sorry guys, like I said before, you're our guinea pig. I hate to keep saying that to you, but it is true. Okay, but we'll learn from you. Okay, hopefully we'll do a good job. I'm sure we'll do a good job. But just to let you know, we don't know everything. We do what we can. All right, continuing on. So I need to know how many terms. I've got it. Now, I also need to know the first term and the last term. Well, that's easy. To get the first term, I put 1 in fry. To get the last term, I put 28 in fry. So let's do it. So u sub 1 equals -2 plus 4 times 1. So u sub 1 equals 2. All right. Just so you're not getting confused, I'm just going to say u sub n rather than actually telling you how many numbers there are. U sub n equals, I'm going to put 28 in for I. So -2 plus 4 times 28. Grab your handy dandy calculator. I'm doing the same. I'm getting 110. Okay. Now that we know how many terms, there are, we know the value of the first term, we know the value of the last term, we can now just use the formula and finish this up. Okay. So I'm going to say that S sub, now I can say it. There were 28 terms. So S sub 28 equals 28 divided by 2 times the quantity, 2 plus 110. Again, all I'm doing is substituting into our formula for the sum of an arithmetic sequence. Grab your handy dandy calculator. You don't need to show us any more work than that. And see if you get the same thing I did. I got S sub 28 equals 1568. And that's our answer. Okay. All right, let's take a look at number 4. Number 4, well, that one looks like it's geometric. Okay, how do I know? Well, this one is geometric because we have an exponent. Okay, this was arithmetic because it's linear. Okay, so I'll say that again. I knew this was arithmetic. I knew to use my sum of an arithmetic series formula because it's a linear expression. We just have a variable raised to the first power. I knew this was geometric because it's exponential. It's exponential because, again, we have a power with a variable in it. Okay, And that's all we're going to be doing with you, so it's not like I'm going to throw a weird one at you. Okay? All right, so let's write down the formula for a geometric series, and then we can decide what we need to know to be able to find the sum. So if you remember this formula, S sub n equals u sub 1 times 1 minus r to the n divided by 1 minus r. Okay, so let's see. So I need to know my first term. Piece of cake, we can do that. I need to know how many terms. Piece of cake, I showed you how to do that. I need to know r. Now, since this is the geometric sequence formula, your r is right here, guys. This is your u sub 1. Okay, now I should back up. That may or may not be our u sub 1. In this case, actually, it's not, because we didn't start it at I equals 1. But if this had started at 1, that would be your u sub 1. This is your r. This is your power. So again, I have to back up. Not really u sub 1, because we want to put 3 in to find out what it is. But whatever is raised to your power of variable minus 1 is your r. We don't have to do any work to find that. So what I know is, I know r is negative 5. Okay. All right, let's see how you do. What's n? I hope you said 4. 8 minus 3 plus 1. Upper limit minus lower limit. Always, always, always add that 1 on. I'm sorry, I said 4. All right, I hope you didn't say 4. I hope you said 6. Sorry about that. You can tell I'm tired. All right, so n equals 6. Okay, I went the wrong direction. All right, hopefully everyone's good. So we have n is 6 between 3 and 8, including 3 and 8. Our common ratio is a negative 5. And now we just have to find that first term, which I mentioned. All you have to do to find that first term is replace your I with whatever the lower limit is, which in this case is 3. So it's 4 times negative 5 raised to the 3 minus 1, which is 2. Grab your handy dandy calculator, and I think that you'll agree with me that u sub 1 is 100. Okay, so now we have everything we need to put into the formula. So I'm going to say S sub, well, there are 6 terms that we're adding. So I'm going to say S sub 6 equals my u sub 1, which is 100, times 1 minus, please be careful here, negative 5, make sure you put it in parentheses. We're raising it to the 6th power. We're dividing it by 1 minus a negative 5. Please, please be careful here. Don't do the plus plus thing until you've written everything out, okay? Because here, I would agree you can do that. You're subtracting a negative, which is adding a positive. Your denominator really is a 6. But if you go plus plus here, you'll be oh so wrong, because your negative 5 is being raised to an even power. When that happens, this number is now positive. You're doing 1 minus a positive answer, which is then going to end up being negative in the long run. And you'd mess it up if you did the plus plus. So please make sure that you always write down the substitution before you try to simplify anything, okay? I'm going to leave you to use your graphing calculator or whatever calculator you have handy and try to do that. I'm going to pause my video. You should do the same. Give it a try. Come on back. See if we agree. All right, we're back. Let's see how you did. I ended up with a negative 260,400. You should get the same thing, okay? So if you didn't, try again your calculator. But again, make sure you're using parentheses. And if you put it in as a 1 plus 5, make sure that you put this in parentheses when you put it in. I just divided it by 6 because that was easier and I didn't have to worry about all that. But again, depending upon the order in which you put your keystrokes into the calculator and where you have your parentheses, this is so easy to mess up, okay? All right, guys, I'm going to turn my paper over and we will begin again. All right, on the other side of your paper, we're going to talk about a sequoia tree. So we basically have 2 word problems here. So let's see what we've got. A sequoia tree that was 2.6 meters tall when it was planted in 1998 grows at an approximate rate of 1.22 meters per year. Write down a formula to represent the height of the tree each year if you use the height of the tree in 1998 as the initial height. Okay, so these can be a little bit tricky. So tell you what, guys, I'm going to pause my video. You do the same. Why don't you try it? First of all, decide, do you think this is arithmetic or geometric? And then go ahead and try it. See if you can get a formula. And then we'll come back and we'll see if we agree with each other again. Okay? So again, pause your video like I'm going to do and really sit there and try it. Pause your video. Thank you. Okay, now what you'll notice, guys, as you came back is I have two different answers. How the heck can you have two different answers, Ms. Bergen? Well, it kind of depends on your point of view. Hopefully IB wouldn't do something like this to you, or if they did, they would have two answers depending on how you went with Part B. Part B, we all should end up with the same answer regardless of how we read this. But really, it all comes down to what do you consider about that initial height? If you think about that initial height as in like the year zero, you know, then the rule would be 2.6 plus 1.22n, because if I put 0 in for n, I get that it's 2.6 meters tall, okay? And if I put 1 in for n, then it's 1.22 plus 2.6, which is, you know, whatever that would be, 1.1, no, 3 point, can't do this in my head now, 3.82. So if you get the idea. So it all depends on your point of view. If you're thinking about it as year zero, then this is your rule. My guess is most of you thought about it as we've been teaching you, that 1998 would be the first year I planted it. If you think of it that way, then you're going to use the formula we've been using with the n minus 1. See, that's the whole point. Do you just use n or do you use n minus 1? It depends a little bit on your point of view. You'll see later where that's going to affect what you do down here, okay? But if you went this direction, then you do your n minus 1 times 1.22, and when you simplify it, you should get u sub n equals 1.22n plus 1.38. How do I check it? Well, if you're saying year one is the initial height, if I put 1 in for n, I do indeed get what it started off being, which is 2.6, okay? So again, to some degree, it's your point of view. Now, depending on your point of view, and I don't want you necessarily changing your answer, guys, go with whichever way you went. I mean, unless you did it wrong, then you should change your answer. But I want you to go ahead and try Part B. If you went this direction, go ahead and do Part B. Let's see what you get. If you went this direction, let's see what you get with Part B. Again, one of them's trickier than the other. It all depended on which formula you went with. So why don't you pause your video again, as I'm going to, and try it, and we'll see if we get the same thing. Remember, we should get the same answer regardless of which formula we went through. All right, I'll see you in a moment. Pause your video. All right, and we're back. And again, I just showed you both ways. So if you thought that 1998 was year zero and you were using this formula, then because it was year zero, there's 22 years between 1998 and 2020 because of the extra 0 in there, okay? So therefore, I just do 2.6 plus 1.22 times 22, and I get 29.44 meters. If you think of 1998 as year one, then you're using the n like I showed you on the previous page, where you subtract the numbers and you add 1 to it. So you have 23 years, okay? Again, if you're using year zero, and you have 1 less year than if you're thinking of that as year one. That should make sense to you. So we have to put 23 in there, and we still get the same answer. So like I said, guys, please be careful on those. My guess is most of you would have used this formula, but I have a sneaking suspicion most of you would have used 22 here instead of 23. You have to be very careful about that. It all goes to, is what you're using really the first term, or is there a term before that? Okay, so that's how you do a problem like that. All right, now Part C. You should know how to do these by now. So once again, I'll read it with you, but then I'm going to go ahead and pause my video and have you guys try it again, because you have done percentage error a number of times by now. So you should know how to do this without me sitting here and doing it step by step with you. So we know that the actual height of the tree in 2020 is 33 meters long, sorry, 33 meters tall. Oh, by the way, just make sure you always put meters on your answers, you know, or when you write it in a little sentence, put meters on there. IB is really big on the unit penalty. Actually, you lose a mark on various problems when you forget to put the units on your answer. So anytime you know the units, please put them in your answer. Okay. All right. So anyhow, as we said, the actuality is it's 33 meters tall, not 29.44 meters. We want to see what is the percentage error of our estimation. So once again, pause your video and come back and see if you do it right. I'll talk to you in a moment. All right, let's see how you did, guys. Hopefully you set it up correctly. It should be your estimated or your approximated, however you want to say it, value first, minus the actual one, the exact one, divided always by the actual or the exact, multiply your answer by 100. Don't forget to take the absolute value, because in this particular problem, it would have been a negative answer. And if you put a negative answer here, you're going to lose a mark on your answer. Percentage error is not a negative answer. It's always positive. So that's why you put the absolute values in there. Okay. You don't need to write down all the decimal places, although I guess I really probably could have shown it to you. But again, just calculator-wise, just so you can see what my work was. There you go. There is the answer. You could write it all out. It's never a bad idea. I probably would still not put the negative answer on there. But then we're rounding to 3 significant figures, which would be approximately 10.8. All right, one more to go, guys, and then we're done. Again, we're sorry that we're kind of making you watch the video to learn this. So I hope everyone does watch the video. Obviously, if you're answering this, if you're listening to me saying this, you are watching the video, and good job. We appreciate it. All right. When Kenzo starts Bright Academy, the school fees are, this is Japanese yen, as it says here. So basically 2,500,000 Japanese yen. The fees increase by 2% each year. Kenzo attends the school for a total of 6 years. Wow. 2.5 million yen for a school fee. Sounds like a whole lot of money. I mean, it still is, but Japanese yen, it's a different kind of conversion rate than for United States. So I know that sounds like a crazy amount, and I'm sure it still is, but that's a different conversation of what that really is in American dollars. All right. So anyhow, the fees increased by 2%. That should be a clue to you on whether this is an arithmetic problem or a geometric problem. So what do you think? If you're thinking to yourself geometric, you are correct. When you're increasing by a percentage, then that is geometric. Okay, so we're going to first write down what we think the common ratio is. Then we'll calculate the school fees in year 6, and then we'll find out how much total fees would be paid in the 6 years that Kenzo goes to the Bright Academy, okay, in yen. That'd be quite a bit. All right, again, this is one of those things where I want to see what you do. So why don't you go ahead, pause your video one more time, write down what you think the common ratio is, then check back and see if indeed you are correct. And we will be right back. I would say after these messages, but I don't have that capability. Well, I probably do, but I'm not going to do it. All right, see you in a bit. And we're back. All right, guys, I got 1.02. Now, my guess is there's a few out there who wrote 0.02 as the common ratio. Oh boy, no. And I think you'd catch the mistake when you tried doing part B. You might recall that if your base in an exponential is greater than 1, then it basically will increase. We call this an exponential growth. If your base is between 0 and 1, then it's actually an exponential decay and it will go down. So if you make the mistake of making R a 0.02 and you use that as your base when you use your formula, yeah, the price is going to go down in fees to almost like non-existent. And that should not seem right when we're supposed to be increasing it by 2% a year. It should be going up over time. So hopefully you'll catch the mistake if you try to do a second part like part B and it's not making sense to you. But you always want to basically add 1 to your decimal. So convert the 2% to a decimal, which is 0.02, and add 1 to it. Okay? All right. So let's see how you do on part B, guys. Calculate the school fees in year 6. So again, this is a geometric sequence because it says in year 6, not through 6 years. If you'll notice, part C says total fees. That one we're going to use our sum formula. But here, because it's just in year 6, you're going to use your sequence formula. Why don't you go ahead and again, pause the video again, try to do a sequence for me, come back, let's see if we agree. I realized I didn't tell you what to round to. So I'll tell you what, guys, go ahead and do 3 sig figs for me. First, write down what your calculator display is, and then round it to 3 sig figs, because that's kind of the rule. If we don't tell you what to round to, that's what you're supposed to do. So since I didn't tell you, let's go in that direction. Okay? All right, I shall return. All right, so again, you're just using your geometric sequence formula, n minus 1. You could have just said 5. I just want to make sure I was showing you where I got that from. This is what my calculator said when I did it. And again, you want to go 3 significant figures, which ends up being 2,760,000 yen. Okay, you could put the little JYN in front. I kind of didn't do it at first, so I just threw the word yen at the back, which is perfectly fine. Okay. All right, so again, last one, calculate the total fees paid for 6 years that Kenzo attends Bright Academy. So again, when it says total, you should be thinking, that's the sum one. All right, I'm gonna use my S sub n formula. You know what to do, go do it. I'll be here waiting for you when you get back. All right, almost done, guys. So here we are. So we should have put in your first term. That would be your 2,500,000 Japanese yen. I use the formula, the 1 minus r to the n over the 1 minus r. I know the formula booklet probably has the other direction, which is r minus 1 and then r minus 1. You should get the same thing no matter what. So after I put all that lovely stuff in, make sure again that you have parentheses if you throw all this in the calculator at one time. This is my exact answer, but we don't want that exact answer because it doesn't say anywhere what to round to. So we're going to go 3 significant figures. So that would be approximately 15,800,000 yen for 6 years at the Bright Academy. I sure hope Kenzo ends up being bright at the end of all that money. Okay, parents hope so too. All right. So anyhow, long story short, guys, that is our presentation on sigma notation and a little bit more review on some of those word problems because they can be a little tricky sometimes. Your homework that we would like you to work on, whether it's before the weekend or on your day off or whatnot, would be the sigma notation worksheet. This is where we are right here. So again, sigma notation worksheet. We are going to post you a quiz on Monday. We'll let you know when we expect you to have that done, but it's just being posted here. And again, we'll talk to you in class about when that is actually due, because off the top of my head, I don't remember when we said we were going to do that. So we're probably going to give you the week, but I'm assuming it would be Sunday, but you know, that we'll want you to either submit it or just show. So I've got to double check my notes on that. But you talk to Mrs. Jensen or you talk to me personally when you see me. Okay. All right, guys, have a great rest of your day. If you're watching this on your day off, I apologize for that, but now go have a nice little day off, okay? And we'll see you next time. It'll be Mrs. Jensen next time, okay? All right, bye-bye, guys.